Welcome to Google Cloud Dataflow. I'm Megan Tyner. I've spent months developing this course, which is aimed specifically for the data engineering certification. This is part one of the Dataflow lesson series. Any video that says optional in the title means it will not cover testable material. However, all lessons are valuable in order to both understand testable material and actually use Dataflow with Beam. Dataflow can be anywhere from 8 to 11 questions on the exam, making it and BigQuery the two most important test subjects. And as such, there is a lot of information we are going to cover. In this lesson, we're going to cover a broad overview of Dataflow with Apache Beam. So let's get started. In the Dataflow portion of Google's data engineering certification, you can expect to receive somewhere between 7 and 11 questions. I've broken down the categories I think would be the most useful to learn. Those are when to select Dataflow, both basic and advanced. For our studying purposes, we are going to expect one of each. Expect one question for design considerations, determining your input and output sources, along with testing using a runner. We'll be covering basic concepts such as flatten transform, the par_do function, the user-defined function, or doFN, and using cancel to shut down a pipeline as soon as possible. I'd plan for only one test question from this category. Next, we'll get into the more advanced concepts such as windowing, triggers, timestamps, and watermarks. I'd plan for 3 test questions on the advanced concepts. And finally, we'll cover Dataflow security and IAM roles. Plan for 1 to 2 questions on security. When to choose Dataflow Basic. Dataflow is a fully managed serverless tool. It uses open source Apache Beam SDK. Note the asterisk. That means it's a really important test subject. It supports expressive SQL, Java, and Python APIs. It supports real-time streaming and batch processing, along with Stackdriver integration. Use cases for Dataflow. Fraud detection, personalization of users' experiences, along with IoT analytics. A data engineer's job consists of managing extract, transform, and load, or ETL pipelines. Now, you don't always use an ETL pipeline, but that's what we're going to be focusing on for these lessons. For companies using Google, this process happens using Cloud Dataflow. Dataflow transports data through a pipeline. First, it must extract the data from a source. Sources can include Cloud PubSub, BigQuery, cloud storage, and external sources such as Kafka. It then undergoes a series of transformations before eventually becoming loaded into a sink. Sinks can include cloud storage, BigQuery, Bigtable, and CloudML. Let's now get into a very, very broad, basic overview of what's going on behind the scenes. First, you have your driver program. Now, this is a program that you write using Apache Beam SDK in either Java or Python. This defines your pipeline. It is submitted to a runner for processing. Your pipeline refers to a full set of transformations your data undergoes. Your pipeline runner is software that manages the execution of your pipeline, i.e. Dataflow. This acts as a translation to the back end. This can also run local driver programs for testing and debugging. The back-end system is often a massively parallel processing system, and this, along with the pipeline runner, make up Cloud Dataflow. Pipelines typically create an initial P collection by reading data from an external data source or from in-memory data. Your P collections are used in the pipeline. They represent data as it is transformed within the pipeline. It represents a potentially distributed multi-element data set, both batch and streaming data. Batch data in a P collection is when it comes from a fixed source, such as a file. The data set is bounded and treated as a batch. Stream data in a P collection comes from a continuously updating source, like a smart device, and is treated as unbounded data. Your transformations represent a data processing operation. It is a step within your pipeline. Each transformation takes one or more P collections as inputs and generates 0 or more output P collections. Your B transforms uses P collections as inputs and outputs. Your multiple transforms are steps that will define your pipeline. The pipeline lifecycle has 3 stages. And now this is under design considerations. Design, create, and test. When designing your pipeline, you're going to be thinking about the pipeline structure and the transformations that will be applied within, and then determining your input and output methods. Then you're going to create your pipeline, and this starts with substantiating a pipeline object, and then implementing the transformations that were previously identified. Then you're going to test your pipeline. So debugging a failed pipeline execution on a remote system can be quite challenging. So Google recommends that you perform local unit testing on your computer because it's much easier to pick up potential errors and identify and fix bugs before it is executed remotely. You're going to want to do this using Apache Beam's direct runner, and this is a potential test question. So make sure you write this down. Let's now take a minute to look at considerations when designing your pipeline. First, location of your data. Where will your data be sourced? Where is the input data for your pipeline stored? How many different sources do you have? Second, input data structure and format. What does your source data look like? This will determine your initial transformations. Third, transformation objectives. What are you trying to do with your data? What is your goal? This will determine the set of transformations that need to be applied within your pipeline. Fourth, output data structures and location. Where does your data need to end up, and how should it be structured? Next, we're going to go over pipeline structures. Now, these videos might go a little fast, but I have all the notes that you need to copy down on the slides, so you can just pause the video at any point and copy down the notes that I have on the screen. So this one right here is just your basic pipeline, and it's linear from input to output. Next, we're going to go over a branching P collection pipeline. A branch can be formed where 2 different transformations are applied to a single P collection, which results in 2 different output collections. Now, in this example, it could be that your transformation 1 operates on positive numbers and your transformation 2 operates on negative numbers. A branch can also be formed at a transform. In this particular example, we have a single transform that outputs to multiple P collections, giving a main output plus an additional output. The transform operates on positive numbers and generates PC1, and also generates PC2, which contains the negative numbers. A pipeline branching can be merged. Generally, you'd need to merge all the branches of your pipeline at some point. Now, this can be achieved with a flatten or join transform. Our final structure is a multiple source pipeline. The data from these sources can be independently transformed before being merged with other branches using a merging transformation. A Dataflow pipeline represents a directed acyclic graph, or a DAG. Now, this is a graph with a finite number of vertices and edges. There are no directed cycles, so it's not possible for the output of a transformation to become the input for the same transformation. Now, this is not going to be a test question or anything like that, but it's still useful to just know. There are 5 steps when designing your driver program. Your first step is going to be to create the pipeline object. Your second step is to create a P collection or P collections using reader create transform. These are your input P collections. Your third is to apply multiple transformations as required. P collections are implicitly created to manage the transfer of data between your specified transforms. 4. Write the final P collections to the pipeline sink. Remember, the sink is where your data ends up. Your 5th and final step is to execute the pipeline using a pipeline runner. So, what's the main takeaways here? What should I focus on from this video? Well, we've technically only answered 2 potential test questions. The first one being when to select Cloud Dataflow. And remember that there's going to be some version of this one answered for pretty much all of the Google products that you're being tested over. So here's an example. Your customer is looking to migrate their data pipelines to the Google Cloud Platform. Their developers are very familiar with Apache Beam. Which managed service would you recommend? Well, we know that Cloud Dataflow is a fully managed service, so check. We also know that it handles data pipelines, check. And the biggest clue of all, that they're familiar with Apache Beam, check. Cloud Dataflow. So here's another one. Your organization needs to be able to reliably handle ever-increasing amounts of streaming telemetry data. Well, we know that Cloud Dataflow can handle streaming data, process it, and economically store analyzed data. What services should you recommend for this task? Okay, so we've got streaming telemetry data. We're going to use Cloud PubSub as our source. We're going to process it with Cloud Dataflow. And then we're going to load it into BigQuery as our sink for our analytical data. So that one's a little bit more advanced because you need to know that BigQuery, what BigQuery does. And by the end of this, and Cloud PubSub, and by the end of this, you will. So here's our last one, design considerations, testing. You want to make changes to a Cloud Dataflow pipeline that is currently in production, which reads data from cloud storage and writes the output back to cloud storage. What is the easiest and safest way to test changes while in development? Well, we went over this. Use a direct runner to test run the pipeline using local compute power and staging storage bucket. So we went over the direct runner, and that's through Beam programming. That's something that Apache Beam offers for testing. So it's highly recommended that if you see that on the test, choose it. This completes the first lesson on Dataflow, which covered a very broad overview of both Dataflow and Beam. Join me on the next lesson, which will be completely optional because there's no testable material in it, but I recommend it because I'm going to be covering Beam basics, which will be helpful for understanding the testable material that I will introduce later.